Hello everybody! Today I can draw conclusions from parallel lines by following my transversal and determining how many angles are inside and outside the parallel lines. So this picture should look very familiar to you. We talked about this earlier this year. All the angles that are the same are congruent. All the angles that are different are supplementary. So again, if they're both acute or both obtuse, they're the same, they're congruent. If one's acute and one's obtuse, then they're supplementary, they add to 180. Now what we're going to talk about today is some of the special names of the pairs of angles that are congruent. And we're going to start with corresponding. So you know what, I can probably type this to make it a little bit neater. So or not. Corresponding angles are angles that are in the same position. So I see two clusters of four. I see four angles here, and I see four angles here. And each cluster has a top left, a top right, a bottom left, and a bottom right. So if two angles are in the same position, they are called corresponding. So angle 1 and angle 5 are both top left, so those are corresponding angles, those are congruent. Angle 2 and angle 6 are both top right, those are corresponding, those are congruent. 3 and 7 are both bottom left, they're congruent, they're corresponding, and 4 and 8 are both bottom right, those are congruent, those are corresponding. So my pairs of corresponding angles are 1 and 5, 2 and 6, 3 and 7, 4 and 8. Now, how many are inside, how many are outside? So let's just take a look at one pair. Let's go back to the 1 and 5. Now, when I'm talking about in or out, here's what I'm talking about. I'm going to color in between the parallel lines. So hopefully everyone agrees that this whole blue area is the area that's between the parallel lines. So I have one outside and one inside the parallel lines. One's in the blue area, one's out of the blue area. That will always be the case for corresponding. Corresponding angles is always one in, one out. Next, let's talk about alternate interior angles. And alternate interior angles are always 2 in. So let's break down alternate interior. Let's break down that phrase. Interior means inside. They have to both be inside. Alternate means on opposite sides of the transversal. So 3 is interior. It's to the left of the transversal. 6 is interior. It's to the right of the transversal, right? This is my transversal, this line. The 3 is to the left of that line. The 6 is to the right. Therefore, 3 and 6 are alternate interior angles. There's one more pair. 4 and 5 are both inside. They're 1 on the left, the 5's on the left, the 4's on the right. So those are alternate interior angles as well, and alternate interior angles are congruent. So the example of the alternate interiors would be 3 and 6, 4 and 5. And the last pair is alternate exterior angles. And since they're exterior, they're going to be 2 out. So alternate again means opposite sides of the transversal, but now they're exterior, so they're going to be outside the parallel lines. So 1 and 8 are both exterior. The ones on the left, the 8's on the right of the transversal, so they're alternate. So that's one pair, and the other pair would be 2 and 7. So my 2 pairs of alternate exterior, 1 and 8, 2 and 7. So when you have parallel lines, you're going to either conclude that you have congruent corresponding angles, congruent alternate interior angles, or congruent alternate exterior angles, depending on how many are inside the parallel lines and how many are outside. If it's 1 in, 1 out, it's corresponding. If it's 2 in, it's alternate interior. If it's 2 out, it's alternate exterior. Now I'm just going to warn you, these are long definitions that we're going to use. So basically it's going to be one of 3 things. You're going to either have parallel lines cut by a transversal create congruence. That's how to always start. Then it's going to either be corresponding angles, alternate interior angles, or alternate exterior angles. So it's going to always start with parallel lines cut by a transversal create congruent, and then it's going to either be corresponding if it's 1 in, 1 out, alternate interior if it's 2 in, alternate exterior if it's 2 out. All right, we did a lot of talking. Time to do some questions. Now, I want to see, I feel like this wasn't number 1. I guess it was 3, 4, 5, 6. Now, I want to see this picture whenever I see parallel. So my given was VA is parallel to KN. So what I want to do is I want to extend my parallel lines and then find and extend my transversal. Now I see 2 transversals here. I'm going to deal with one at a time. I'm going to start with this one. Now I see this picture. There should be 8 angles. So I want to see 8 dots at those 8 angles. I see 1, 2, 3, 4, 5, 6, 7, 8. Those are my 8 angles. Now, here's a question you have to ask yourself. In each cluster, which angle is the angle of a triangle? Well, this is the angle of a triangle, and this is the angle of a triangle. No other of those dots are an angle that's an angle of a triangle. This one here is close. It's an angle of a quadrilateral, not an angle of a triangle. So my conclusion is going to be angle AVK is congruent to angle NKE. And now my reason. Let's color inside the parallel lines. Is it 1 in, 1 out, both in, or both out? Well, the top one is in, the bottom one is out. 1 in, 1 out is corresponding. So my reason is going to be parallel lines cut by a transversal create congruence. Again, since it was 1 in, 1 out, corresponding angles. Yes, you have to write the whole thing. Sorry, not my rule. but you have to write that whole thing out. Now there's a second transversal. So I'm going to extend that. I'm going to make my 8 dots for that one. Which of these 4 up top is the angle of a triangle? This one. Which of these 4 is the angle of a triangle? This one. So I can also say that angle VAN is congruent to angle KNE. And it's the same reason. One's in, one's out, so it's corresponding. I don't have to write the reason twice, and that's it. These are your conclusions, and this is your reason. Let's try another example. It might take a little bit for you to get this, but as long as you do what I ask you to do, you extend the parallel lines, you follow and extend your transversal, it comes together pretty nicely. So this is number 2. I told you that MY was parallel to RE. So we're going to extend our parallel lines, and then we're going to find and extend our transversal. I see 2 transversals. I'm going to do one at a time. I'm going to start with that one. I want to see my 8 dots. 1, 2, 3, 4. Follow the transversal. The transversal hits the other parallel line at E. 1, 2, 3, 4. Nothing's happening at S. The angles are where the transversal hits the parallel line. Up here, which of these is an angle of a triangle? This one. Which of these is an angle of a triangle? This one. Are they both in? Are they both out? Or 1 and 1? No, they are both inside the parallel lines. So since they're both inside, that's going to be alternate interior. So I'm going to say that angle YMS is congruent to angle SER. And the reason, again, it's long. Whenever you see parallel, it always starts with parallel lines cut by a transversal, create congruent, and then since they're both in, alternate interior angles. Now there's another transversal. 1, 2, 3, 4, 5, 6, 7, 8. Which of these 4 is an angle of a triangle? That one. Which of these 4 is an angle of a triangle? That one. So that's angle MYS and angle SRE. And the order of the letters don't matter except for the middle letter. R and Y are congruent. And then M and E are congruent. And again, for both pairs, they're both in, so they're congruent alternate interior angles. We're just going to go through one more, and then you'll have an opportunity to practice. Number 3, I gave you that CL was parallel. Whoops, that's not the parallel symbol, that's an H. I gave you that CL was parallel to HA. So we're going to extend our parallel lines and then follow and extend our transversal. There's only one transversal in this example. There's only one line hitting both of those lines. That's it right there. I want to see the 8 angles, so it's where the red lines intersect. So 1, 2, 3, 4. 1, 2, 3, 4. Which of these is an angle of a triangle? That one and that one. So it's angle SYC is congruent to angle AKN. And the reason, well, it always starts with parallel lines cut by a transversal, create congruent. Now, are they both in? Are they both out? Or is it one and one? So I like to color in between. Both of those angles are outside the parallel lines. So since they're both out, they are alternate exterior angles. Since there was only one transversal, there's only one conclusion from this one. In the two previous examples, there were two transversals, the red and the green, and this one had two transversals, the red and the blue. So 4, 5, 6 are just like 1, 2, and 3. Use them as a model. Follow and extend your transversal. Put your 8 dots in. Whichever of those 8 dots are angles of a triangle or the angles that you want. State that they're congruent. Your reason is always parallel lines cut by a transversal create congruent. Then it's either corresponding angles if it's one inside, one outside the parallel lines, alternate interior angles if they're both inside the parallel lines, and alternate exterior if they're both outside the parallel lines. Your classwork/homework is to finish this worksheet. Have a great day.